Hello friends. The lift is a type of vertical transport equipment that moves people or goods between floors of a building. Generally, lift is powered by electric motors that either drive cables, hoist, or pump hydraulic fluid to raise a cylindrical piston like a jack. Elevators are of two types. One, hydraulic elevator. Two, traction elevator. Hydraulic lifts are powered by electronic pumps which transmit the hydraulic fluid to the jack. The lift has a piston at its base which will push it up. On the other hand, traction lifts use ropes, sheaves, and counterweight for moving up and down. Both systems have their own set of pros and cons. Traction elevators are the most widely used elevators all over the world. Shaft. It is also known as hoistway. It is the space in which one or more elevator car moves. This space is enclosed by fireproof walls, pit, and ceiling for the travel of one or more elevators. Headroom. It is also known as overhead. It is a part of shaft between the level of the highest stop and the shaft's ceiling. Travel height. It is the length of cabin's travel between level of the lowest and the highest stop. Pit. It is a part of shaft below level of the lowest stop. So if we want to calculate shaft height, it is equal to pit plus travel plus overhead. Machine room. It is a special room accessible only for the authorized persons which contains the lift drive unit, control panel and motor. It is often placed above the shaft on the very top floor. The machine room is an integral part of the elevator. With advancements in technology, the machine room is getting smaller and smaller every year, and some systems even have them installed inside the shaft. They are also known as machine roomless elevators or MRL elevators. Guide rails. They are generally made of steel and their shape is like an English letter T. They are installed vertically in a shaft to guide and direct the course of travel of an elevator car and elevator counterweights. Drive unit. Drive unit is generally placed in machine room and it is used to operate the movements, speed and torque of an elevator. If your elevator often suffers from slow starts and stops or seems to make sharp, sudden movements, the drive could be to blame. Control unit. It is also known as controller or control panel. It is placed in machine room which is generally at the top of the elevator shaft. When we press any button in a lift, the signal goes to the control unit and then it is translated through the system to tell the motor whether to move up or down. Once the elevator has reached its destination, there is a signal sent to the control room for it to either stop and let passengers board or exit it. Counterweight. It is a unit consisting of steel weights which counterbalance the weight of the car and to which the suspension ropes are attached. The weight of counterweight is equal to weight of car itself plus 40 to 50% of total weight it can carry. You can see in this picture, the car is located here. When the elevator car goes up, the counterweight goes down and vice versa, which helps in three ways. The counterweight makes it easier for the motor to raise and lower the car. Just as sitting on a seesaw, assuming the seesaw is properly balanced, you can bob up and down any number of times without ever really getting tired. Quite different from lifting someone in your arms, which tires you very quickly. Hence the motor needs to use much less force to move the car either up or down. Suppose the lift is loaded at its full capacity, which means it weighs more than the counterweight. But in this case, the motor has to lift the difference in weight between the two and supply a bit of extra force to overcome friction in the pulleys and so on. Since less force is involved, there is less strain on the cables, which makes the elevator a little bit safer. The counterweight reduces the amount of braking the elevator needs to use. Imagine if there were no counterweight. A heavily loaded elevator car would be really hard to pull upwards, but on the return journey, it would tend to race to the ground all by itself if there were not some sort of sturdy brake to stop it. The counterweight makes it much easier to control the elevator car. Guide shoes. Guide shoes are the devices which are used to guide the car and counterweight along the path of the guide rails. There are two types of guide shoes. One, roller guide shoes, roller guides, and two, sliding guides. Roller guides use rollers that rotate on guide rails. It has a set of 3 wheels that roll against the guide rails. You can see roller guide shoes on rails in this picture. Sliding guides. Guide shoes which simply slide along the faces of the rails. The sliding insert or jib may be metal, requiring guide rails to be lubricated, or may be plastic material which is self-lubricating. Guide shoes shall be made of cast iron, brass, or synthetic materials such as nylon, fiber-based hilum, etc. Sheave and motor. Sheave, also known as pulley. It has grooves in it and lets the rope be lifted, raised, and lowered. It is the motor that keeps the sheave moving in the correct direction, taking people where they need to go. Speed governors. Most elevators have an entirely separate speed regulating system called a governor, which is a flywheel with mechanical arms built inside it. Normally the arms are held inside the flywheel by springs, but if the lift moves too fast, they fly outward, pushing a lever mechanism that trips one or more braking systems. First, they might cut power to the lift motor. If that fails and the lift continues to accelerate, the arms will fly out even further and trip a second mechanism applying the brakes. Some governors are entirely mechanical, others are electromagnetic. Still others use a mixture of mechanical and electronic components. It is usually attached to the bottom of the car and it is also known as governor rope. Cable or rope. Elevator ropes are highly engineered and made of steel with other composites. Also, they are not single wires but several strands of various sizes wrapped together. A typical cable or rope can have over 150 strands of wire precisely designed to be strong, flexible, and give long life. As I am not able to complete all the information about this topic in a single video, I am going to cover remaining components and some important information about elevators in my next video. So stay tuned. Thanks for watching.